Organic chemistry. So I want to look at hydrocarbons first. Hydrocarbons. So in chemistry, hydrocarbons are compounds made out of compounds made from hydrogen and carbon only. Compounds made from hydrogen and carbon only. That's what we call hydrocarbons. Are we together? Hydrogen and compound only. So we mainly have alkanes and alkenes. Those are hydrocarbons. So these ones are known as saturated because they are stable. Saturated. Very stable. Altogether. And don't easily react. And these ones are unsaturated because they've got a double bond. Unsaturated because they have a double bond. One pair of a double carbon-carbon bond, which makes them unstable altogether. Unstable and can easily react. So in chemistry, we said hydrocarbons are carbons made from carbon and hydrogen only, and we have mainly two types, alkanes and alkenes. Alkanes, saturated hydrocarbons, which don't easily react. Alkenes, unsaturated, because they have one pair of a double carbon-carbon bond, which makes them easily unstable and can easily react. Clear? So we get these hydrocarbons from cracking. I'm sure you know that. In your textbook, you see that there's the table for diagram for cracking, which you should know. For cracking of crude oil, so for mainly cracking of your petroleum, to produce different products. So we crack them under very high temperatures, and we produce what we are talking about. Are we together? Now let's start with the unsaturated ones. The saturated ones, sorry, alkenes. So alkenes, these are a homologous group. What is a homologous group? With what's the functional formula? CnH2n plus 2 formula. A homologous group. What are the characteristics? Well, if you say something belongs to a homologous group, it has the same functional, they say the same functional group. Are we together? They show similar trends in physical and chemical properties, as mainly chemical properties. Are we together? Homologous group. Now let's start with the alkenes that we're talking about. So I'll say alkenes. I said they have a formula CnH2n plus 2. So the first alkene, is when N is equal to 1. Look at this. When N is equal to 1, I simply have C If I put 1, there's 2 plus 2, H4. And we call that methane, which is a natural gas at room temperature. So this is your natural gas. How together? Gas at room temperature. CH4. So you've got 1 carbon. So remember with this one, we don't have a double bond there. Like this. That's the structure. So this is the structural formula, the one that I've drawn here. So we talk of structural formula, molecular formula. The next one is when N is equal to 2. When N is equal to 2, look at this, we have C2. Use your formula, 2 times 2 is 4 plus 2, 6. H6. And we call that what? E thing. For us to draw that like this. Hydrogen, 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 hydrogen. There, it's there. The next one is when N is equal to 3, and that one is C3H8. And we call that propane. Propane, sorry. Propane, like this. Are we together? Are you guys there? So we call that propane, and I'm sure it's easy. We can easily draw that. Okay. We call that propane. So it's when N is equal to 4. Okay. Now, the next one is when N is equal to 4. So now I have 4 carbons. So using my formula is 4H10, and I call that butane. Like this. 4 carbons. But now starting from 4, I start having what is called isomers. Isomers, same structure, same molecular formula, but different structural formula. So let's start from there. Then we explain that. So starting from butane, that's when we start having isomers. So we said butane, normal butane is C4 carbons. No double bond, that was an alkane, like that. Then these last carbons are bonded to 3. The rest is to 2 in between. Okay, like this. C4H10. How do I have an isomer? Instead of having a 4 chain, I can have a 3 chain, like this. 1, 2, 3. Then I'll show you what will happen. Like this. So there is still okay. But then now, instead of, I will introduce a carbon here, a CH3. Then I'll explain that. 1, 2, 3, 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7. 7 plus 3, 10. So this one, 4 carbons. So same structural formula, same molecular formula. So it's again, they're the same. This one again, C4H10, but different names. Huh? So this is butane, your normal. And this is butane. Now let's see how we name this. You count the number of carbons, even if you count from this 1, 2. So this group here is called a methyl group. I want you to pay attention. It's called a methyl group. It's on which carbon? 1, 2. It's on the second carbon. So I start with that. It's called 2-methyl, like this. 1, 2, 3. So if I replace this, it will be simply a normal propane from 3. So 2-methyl propane is an isomer of butane. Are we together there? Clear? The guys are quiet.
Sir, is there any difference if you say but2ane?
Which one? No, that's wrong.
For the
This is
second one,
methyl.
if you name it.
That's not correct. Because this is methyl. It's called a methyl group. A CH3 is a methyl group. CH3, CH2 is called an ethyl group. So this is a methyl, one carbon. So it's not correct. All together. So it's 2-methyl. 2 is the position where the methyl group is on. Then I'll name my my long chain is 3 carbon, so it's propane. Because if I replace the hydrogen, it becomes propane. So that's why it's 2-methyl propane. Clear now? We'll see what will happen just now. Let's go to number 5, which is pentane. So pentane will be C 5 carbons, your normal pentane, 1, 2, 3, 4. 1, 2, 3, 4, 5. So hydrogen, 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 like that. So this is your normal pentane. So this is pentane. Like this. Was it C5H12 in count? Now let's talk of the isomers. So I'm sure there are 3 isomers, you see that. So instead of having 5, I can almost have the similar thing. I can have 4. So 1, 2, 3, 4, like this. So I'm not having a 5, I can have a 4. Then I need to mention something here, because you are going to ask me. So look at this. What I want is to put a methyl group. If I put the methyl group on this number here, look at this. If I put the methyl group on this, I want you to listen to the rules there. I don't say 1, 2, 3. I always look at the shortest distance. What's the shortest distance? It's 1, 2. So this is a 2-methyl group. Before I even think of the long chain, which is 1, 2, 3, 4. 2-methyl butane. Okay. Now, if I change this, okay, let's remove this, sorry about that, and we put it on this, can you see that the naming is simply the same? It's still the same isomer because I always come from the shortest distance. This is also 1, 2. So it remains 2-methyl or butane. Is it clear with everyone there, or I need to repeat? Tapiwa, is it clear now? It still remains 2-methyl because I always count the shortest distance. So putting it there does not change its name. So it remains 1 isomer. That's what I wanted to explain. So there is 2-methyl butane, an isomer of pentane. Okay, that's the first isomer. This one actually has got 2 isomers. Now, instead of this, I can only have 3. It's possible like this, 1, 2, 3. Then there I have a CH3 group, a CH3 group. Then I have my normal hydrogen, 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 hydrogen. So still I still have 12 hydrogens and 5. Now, what's the name of this? Let's see who can get it correct. Who can get it correct? What's the name? Who can try? Tapio. What will be the correct name there? What will be the correct name, Tapio?
I'm not sure.
But try. Can't say you're not sure. I told you what the CH3 group is called. Okay, and try. Don't have to.
Is
Yes.
ethyl.
Not ethyl. This is methyl, 1 carbon. Ethyl is when we have, ethyl is like this, when we have 2 carbons, when we have a CH3, CH2 like this. Are we together?
Yes, sir.
So that's not ethyl. So that's, look at the position. Position 1, position 2. So this is what confused you, because it's 2 of them. We say 2.2. They are on the same position. But it's 2 of them, I say di. Methyl. Then what's the long chain? 1, 2, 3. So it's a propane. Is that clear? Because you get that in paper one day. 2.2 dimethyl propane. Clear? 2.2. Can I show you the last isomer there? So this one has got actually 3 isomers, not only 2 isomers. Let me show you the other isomer. I'm sure someone tried to when they were giving me a wrong name like this. So instead of here having a methyl, I can have a CH3, wait a minute. What did you make? We made a mistake. This is how many carbons? 1, 2, 3, 4, 5. And you guys are quiet. This is not correct here. Sorry about that. Sorry. This is not correct. 5 carbons, huh? 5 carbons. Can we have 2 there? It's not correct, but these are 6 carbons. 1, 2, 3, 4, 5, 6. Okay, I see that it's not possible. It's not correct. Sorry about that. So, what it simply means, 5 carbons. Oh, what's happening? So that's not correct there. Remember, we're talking of a 5 carbon chain. So we can't have 6. Maybe I simply made a mistake. So we simply have 5. Let's say 1, 2, 3. We said 3, yeah? Okay, 4. Okay, it was correct. 1, 2, 3, 4, 5. Yes, it makes sense. So it was CH3, no, that's correct. I was counting 1, 2, 3, 4, 5. That's correct. So we said this whole thing was 2.2 dimethyl propane. I'm just ignoring, but these are hydrogens, 3 hydrogens there. Okay, so we have 5. So what I wanted to show you is instead of having these 2 here, I can have 1, 2, 3 there. Then there I will have CH3, CH2. Then there I will simply have a hydrogen, 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 hydrogen. So no, this is now the ethyl that we're talking about. Ethyl, not methyl, because it's 2 carbons. So it's on number 2. So it's 2 ethyl. You see that? 2 ethyl propane. Are we together? An isomer of that. Now let's look at the last one. Then we will look at the properties just now of alkanes. Now, hexane, X from hexagon. So it's C6H14. So your normal, I'm going to ignore your normal, and everyone can draw that. Simply a long chain of 6 carbons. The last carbons are bonded by 3. The ones in between are bonded by 2. You now know that. Now let's look at the isomers now. So the isomers, I can have 1, 2, 3, 4. 1, 2, 3, 4, 5. Now, I want you to pay attention to this. Everyone, Makanaka. If I put a CH3 on this, that's what I explained. And if I put a CH3 on this, is the naming different? It's the same, huh? Because I name 1, 2. From this, I can't say 4. I always name from the shortest distance. So again, it will be 2. So it means these two are the same positions. It doesn't matter which position I put the isomer. So it means if I put the earthly there, it remains, so the rest are simply carbons. Huh? I'm sure you figured out the hydrogen, so you figured out by now. Like this. So this is what I mean by what we are doing. So it means this name, if I was to change, to swap this hydrogen with this, the naming does not change. But this is position, it's not position 4, it's position 2, shortest distance. If we put the CH3 there, is shortest distance, position 2. So that doesn't change. So it's 2-methyl. 1, 2, 3, 4, 5. So pair 10. Clear? Makanaga? Pentane, 5 carbons. Now, but now if I change, look at this, 1, 2, 3, 4, 1, 2, 3, 4, 5. If I change and I have it on number 3, now it's very different. Because if I count there's 3, if I count there's 3, yeah? So it means it has also another methyl isomer. Like this. And that methyl isomer is 3, I'm sure you can see that. Is 3-methyl pentane. Clear? But we have more isomers. So instead of having 5, we can have 4. 1, 2, 3, 4. Then your guess is correct with mine. We can have a CH3, CH3. So that we have 6 carbons, like that. Then these are hydrogens, I'll ignore them for now, you don't know. So 2.2 dimethyl, now I have an idea. 2.2 dimethyl, long chain, 4 carbons. So butane. Is that clear? 2.2 dimethyl butane. Now I can also have the same thing. 1, 2, 3, 4. But now on this one, I'll have CH3, CH2. Then this one is simply a hydrogen. The rest are hydrogens like this. Okay. So this becomes a 2-ethyl. 1, 2, 3, 4. 2-ethyl butane. Clear? Brenton, I hope it's making sense. Then lastly, I can have 3 carbons. 3 carbons only. So instead of, remember, we still want to have 6. So 1, 2, 3. Then I can have an ethyl group. And a, yes. Let's see who can get this naming correct here. Hey, what do you do when you have something like this? It's alphabetic. Are we together, Brendan? Alphabetic. This is methyl, ethyl comes first. It's on the same position, 2. So it means 2.2. They're on the same position. But now I'm saying ethyl, methyl, 1, 2, 3, propane. Prop for 3. There. Clear? Now let's quickly look at the reactions of alkanes. Okay, number 1, They don't easily react. They undergo complete and incomplete combustion if you burn them. Complete and incomplete combustion. Complete and incomplete combustion. So I'll pick an example, CH4. If I burn it, complete combustion always produces carbon dioxide and water. Clear? When you have carbon dioxide and water when you are burning, it means this is complete combustion. Carbon dioxide and water. Is it balanced? Maybe no. 1 carbons, we have 4 hydrogens there, so we need to put 4 here so that we have 4 hydrogens. The moment we do that now, we now have 2 oxygens plus another 2 oxygens, 4 oxygens. So we put 2 balance. Clear? So gas, 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 liquids. Incomplete combustion, when it's incomplete, so we have CH4 plus oxygen, we are burning. What's produced, if it's incomplete, we produce carbon monoxide. It's incomplete, plus water. So again, 2 to try to balance. So if we put 2 there, we now have 3 oxygens. So there I put 3 over 2. Because 3 over 2 times 2 from the next 3 over 2 times 2 gives you 3. But now in O level, you don't, A level, you can leave it like that. You now need to multiply everything by 2 so that you eliminate this fraction. So this becomes 2CH2 plus, if you cancel that, this simply becomes 3O2 to give you 2CO. If you multiply by 2 plus 4H2O. Balanced equation. We need to know how to balance these equations. Incomplete combustion and complete combustion. So it's the same for everything. Even if it was butane, it's the same. So for example, if we pick butane, let's look at the equations for complete and incomplete combustion. So if I have C4H10, which is butane, we should all know that by now, plus oxygen. If it's complete, I'll have carbon dioxide plus water. And I said the balancing is important. How many carbons there? 4. So I need to put 4. How many hydrogens here? 10. So I need 5, so that is 10. But the moment I do that, you see that the oxygen is 2 times that, it's 8 plus 5, 13. So I have to put 13 over 2 there. Then multiply the whole equation by 2. So I have 2CH4H10 plus 13O2 to produce times 2, that's 8CO2 plus 10H2O. Let's look at the incomplete. The incomplete there, I'm saying C4H10 plus oxygen. Incomplete, you said carbon dioxide plus water. So let's think of carbons 4, hydrogens 10, 5. So the moment we do that, let's see, we need how many? 4 oxygens that. So 9 over 2. Then you can also multiply the whole thing by 2. That's incomplete. So it's the same. They all undergo, we can all bend them. Then number 2, they can only, you need to write that down, it's very important. They can only react with halogens, which means group 7, with group 7 elements in the presence of sunlight. In the presence of sunlight. And that reaction is known as a substitution. substitution reaction, because we are replacing, we are substituting something. So for example, methane, CH4, like this. If I expose it to chlorine under UV light, that's what we said, in the presence of UV light, one of these hydrogens is replaced by chlorine. So that's what we mean by substitution, like this.
Sorry, sir, please could you explain that again?
Okay. I said they are very stable, they don't easily react. So if you want to react them with the group 7, these alkanes, okay, the alkanes group, you react with sunlight in the presence of UV light. And the reason why it's called substitution is that the chlorine, one of the chlorine, remember chlorine is this. So the chlorine breaks because of this UV light and forms a chlorine radical. The chlorine radical displaces the hydrogen, one of the hydrogen like this, and we form this. So we have removed one hydrogen, then the other chlorine reacts with the hydrogen that is removed and forms hydrochloric acid. That's what happens. If it was bromine here, it would be the same. We are replacing one of the hydrogens with bromine. That makes sense?
Yes, sir.
So remember, this was what was methane. So remember, this is now chlorine, chloromethane. Huh? So this is called chloromethane. Okay, that's that. But now if you continue exposing it, you find that this can also be further replaced by another chlorine. This further be replaced, but it's not this beyond your syllabus. Are we together? So only know that they can only react with the group 7 in the presence of UV light. Otherwise, if you just add them to bromine just in a room temperature, they won't react. Are we together? Clear? Only in the presence of UV light. He said that reaction is called substitution reactions. Okay, we are done. The next lesson we look at alkenes and we'll compare those two. Okay. We'll see you for bio. Those that do bio.
Thank you, sir.
You're welcome.